Hello, everyone. My name is Nick Berenberg, and I'm happy to present what was my thesis presentation. Recently graduated from Cal State East Bay from the Graduate Ecology Program. For anyone who's familiar with the program, my thesis advisor was Dr. Chris Kidding. Today, I'll be talking about large wildlife use of groundwater seep environments, impacts of cows and seasonality amid drought in California's Oak Canyons. What to expect. So over the next 20 minutes, I'll be introducing the project, going over the project's background. I'll define a seep and show you what seeps look like. I'll introduce the hypotheses in which I tested around. I'll show you some methods and materials that were used. We'll go over the results. And during the discussion section, I'll be going over the whys and the whats and what we noticed and why we think certain things occurred. As I said, I'll be doing my best to keep this to under 20 minutes. So I've got to move. Project introduction here. So a few points that stand out here are below, but the overall goal was to understand if cows and seasonality, meaning our wet and our dry seasons here, affect large wildlife use of our groundwater seeps here in the East Bay Hills. There are a few studies in general on groundwater fed seeps and springs here in California. Most of East Bay Regional Park District's land is grazed by cows. We know that there is a growing need for water in the area amid our ongoing drought and climate change in the region. We use trail cameras to record abundance and richness. I like this picture here because it shows where two of our cameras were located. You can see the seeps on the right. There's another seep there on the left. But overall, in general, you get a sense for these lush little mini environments against the brown grass, the backdrop there of a hill environment. And this is pretty indicative of seeps throughout the area. It's pretty common to have these. So now you may know that there are seeps and springs throughout our area. Looking at past studies, we saw one in the Southwest in which testing occurred across a number of water features, and seasonality did affect, meaning wildlife did visit these water features in greater frequency during the dry months. So where do cows come into play? Well, on one hand, we know that cow grazing is beneficial to grassland ecosystems. On the other hand, we know that riparian ecosystems can be degraded, can be eroded by cows. So where do seeps and springs lay within that? They're a little wet environments where we have cows and some of them and not others. So what's the effect on a seep and spring environment when we think about cow grazing? But moving right along, that is a seep, that picture there on the right. So that's in Wildcat Canyon. It's facing west. You can see some water, some pooling there. You can see a turkey. Seeps are simply low magnitude groundwater springs. They'll often no more than muddy puddles, sometimes even just a muddy depression. And it's not, I'm not a geologist. I can't say for sure why we have so many in the area, but in general, it is known that when you have a fault line running in the area, it does tend to disrupt the water table. So I can't say for sure if that's the reason for my 9 particular seeps, why they were, how water got to those, but just some thoughts that went into this. So 2 hypotheses. I'll show you what my thinking was going into this, and this is where we led the testing, or how we led the testing. The first hypothesis was large wildlife abundance and richness will be greatest at seeps where cows are not present. Secondly, I thought that large wildlife abundance and richness will be greatest at seeps during the dry months. So you can think to yourself, how might this play out considering cameras across 9 seeps in our area? So this is the methods and materials slide, and we're showing a camera on the right, and you can see a sample image on the left. 11 species were recorded. Now these are 11 of the large, reliably recordable species. So meaning no mice and birds would come in and out, but we weren't really able to record them at all this site. So the 11 species recorded, seven predators: opossum, skunk, raccoon, fox, coyote, and the 2 cats, bobcat and mountain lion. The 4 non-predators, we had turkey, deer, feral pigs, and squirrels. Our time frame was September 2020 until this past January, and definitely in the middle of our drought here. So that was an ongoing theme, as it is really for all of us when we're dealing with land and wildlife in the area. So this is where our seeps are located. So this is Guerin Regional Park. This is just east of the city of Hayward. So Cal State East Bay is just to the north. You can see the housing development. East Bay's campus is kind of to the picture extended. It's a little bit further to the north. And we're able to walk from campus down to where this Zealy Creek is. And that was the start of our project. And we then expanded it into more sites. So takeaway here, 5 seeps with cows, 4 without cows. And this is the result. So we had thousands of images, most of which, as you all know, if you've dealt with wildlife cameras, most of your images are not actually animals in the pictures, but we sifted through, we got 1,800 separate records, many turkeys. So we'll talk about that shortly, but we removed the turkeys from the data to reduce the skewing. And one takeaway here, because cameras went into the field at different time periods, unfortunately, a couple of cameras are stolen, so we have uneven lengths of time for cameras at seeps. What we did is we did averages per day. So that was a way to normalize our visitation data, averages per day. So even though you could have one camera that was in for just a few months versus one camera that was in for all 16 months. So that's how we did. That's how we smoothed over the differences between the time intervals. So moving right along. So a simple way to do this was simply dry and wet months. And you might be asking, so how do you delineate, say, a May where the first or the last rain occurs? So like we did a rainfall of point, we looked at weather data. The last rainfall of 0.2 of an inch or more, 30 days past that would be a start of a dry period. The last, or I guess I should say the first of the rainy season, then the first corresponding 0.2 of an inch of rain in October would mark the beginning of a wet season. So we use 30 days past for the last rain, and the start of the wet season, like I said, 0.2 of an inch. So that's how we delineate the periods. And you can see that turkeys definitely affected the data here. So the columns to the left, you can see a huge difference. Turkeys definitely preferred the dry months. But when we remove turkeys, wild mammals, that's the 10 species minus the turkeys, and then the 7 predators by themselves, there was an influence of weather and dry periods. So Mann-Whitney U-test. So we had 2 different pools of data. So we didn't want to just go by these simple averages. We wanted to also see some differences when we separate the data. When we analyze the means here of those 2 data pools, we can see that differences were significant for wild mammals when we compare wet and dry months. So there was a significant predictor for wild mammals towards dry months. Differences were not significant for predators. So there was an influence you could see in the averages, but we wouldn't call it significant based on the Mann-Whitney U-test. So what about sites with cows and without cows? So this is another kind of simply dumping all the data into 2 big buckets, with and without cows. And let's ignore the turkeys and just look at the 10 mammal species and those 7 predators. So that's opossums, that's raccoons, that's skunks, coyotes, fox, mountain lion, and bobcat. They visited by a factor of 4 to 1 sites with cows versus without. Pretty interesting. So all the biologists and ecologists, think about why that might be. Mann-Whitney U-test definitely back this up as well. So like the bottom one, you can see that tiny p-value well under 0.05. So differences were highly significant for predators towards sites with cows. Differences were suggestive. So a p-value is still a little bit north of 0.05, but close enough where we would say differences were suggestive for wild mammals. What happens when we combine the 2 sets of data, wet months and presence and absence? So said another way, the two groups of columns to the left is wet months. Two groups of columns to the right are within the dry months. For example, you can see that lighter blue color there, predators, by a factor of 7.5 times higher was the frequency at the cow sites versus the sites without cows. But pretty interesting. In other words, during dry months, predators were most often going to the sites that had cows. Mann-Whitney U-test, we spliced out some more groupings of data here. So within, for example, here, sites without cows is another group of data we chose to look at. But sites where there were no cows, when we looked at wild mammals, there was a suggestive impact towards dry months. So not a huge impact, but suggestive. That p-value is still a little bit north of 0.05, but still an influence towards those dry months. Differences were significant for predators when looking at sites with cows. So like we spoke about, within the sites with cows, differences were significant towards those dry months. Wildlife richness. So this is a little busy. Sorry about that axis there with a lot of verbiage there. But we have averages per camera day. These are all sites with no cows, and you can see the color coding here indicating species. Other, that wraps up into one that's most of the predators outside of coyote. And so my one takeaway I want you to see here is get a general sense of the colors, and now contrast this to this. This is all sites with cows, and you can see more colors. You can see greater variability here. But you can see that purple color is now showing up at the top of the column here with more predators and more species in general. So we can say that wildlife richness was at least a little bit higher at the sites with cows. So let's begin the discussion here. So what happened? So when we look back at the hypotheses compared to results here, so we can go ahead and we can reject, or I can reject my first hypothesis that wildlife species richness and abundance would be greatest at seats where cows are not present. Well, the opposite turned out to be true. So you can see some of the notes here that we spoke about earlier here. Differences were definitely significant for predators towards sites with cows. And there were suggestive impacts as well for wild mammals. The seasonality, what happened here? So data at least partially supports our second hypothesis. Wildlife richness and abundance was greatest during the dry months. Now, it wasn't massively greater, but it was materially higher during the dry months. So animals were definitely visiting the seeps in greater frequency during the dry months. So that held for both our predator abundance and our mammal species. And so here is where we talk about correlation. So this is where during the live Q&A session, I would love to hear from people in the audience about just really any point you might have or question here. But the way I looked at the why, so why did this happen? So the first thing I did, 3 groupings here. You can see 3 groups of bullet points here. Density of cows. So we had on one hand, no cows at 4 sites. On the other hand, we had 2 sites, those open field sites we first looked at, that had very high densities of cows, meaning the ratio was, or the number of cows was almost 1-to-1, meaning when we divided the number of cows versus the total number of images, these 2 sites, that number was almost or close to 1 at least, because almost every image was of a cow. So we had very low wildlife abundance at those 2 locations. Our moderate level of cows, when we think about like the intermediate disturbance theory, for example, this might be related to that as well. So when we think about that, well, we also had a moderate level of cows that had our greatest abundance. At these sites here, we had many small animals. So we also had a lot of predators at these sites. So especially when we look at some of our images that show direct predation, and there's some pictures that we got of a bobcat, maybe it was 2 bobcats, but different images of bobcats catching and eating wood rats on camera. So we know that wildlife species were not just drinking water. So to me, that was a little bit surprising, or at least I wasn't expecting that, but even our grazers were doing things in camera that weren't necessarily drinking water. So historical presence of large grazers. So Thule elk historically used to be in the area. We used to have many other large herbivores in the area before the Thule elk. So we think about cows potentially filling that niche. And no cows at all. 2 creek sites. 2 creek sites had to be used here. We ran out of standalone seeps without cows. The 2 creek sites had very low abundance. Across the 4 no cow sites, we had very high levels of turkey and deer. And then one other thing I would note before moving on, our lower sloped sites underneath an oak or a native bay laurel canopy had the highest abundance. So in other words, when you had a seep kind of at the bottom of a depression, or at least where the ground was flat, and you had our native tree species overhead, that tended to have those sites tended to have higher abundance. So just some interesting points here. And then impacts to data. What would we do differently? What would we like to do in the future? So for sure, we would like to have more sites. So we had nine sites total. That when you have, when you don't have a whole lot of sites, you introduce a potential for confounding influences, especially when 2 of the 4 seeps were seasonal creek locations. So like running water down the creek in the winter, and then a string of pools in the summer. So we'd like to expand this to be able to have sites, more standalone seeps in general. Another impact to the data would be camera distance to the center of the seep. So some cameras, as you all know, when you get out in the field to a site where you may have designed the project, sometimes things turn out to be a little bit different than what you might have planned. In our case, mounting a camera was tricky at times. And some locations, we could put the camera right near the water. And one particular location, that camera was 15 meters back. So that definitely impacts what you do and don't record. So comparison sites. So one last interesting point we did before the project ended, we put a camera up on a ridge far away from any water at all. And that comparison site had far lower anything. So it definitely so definitely our thoughts were that, yes, water is impacting wildlife abundance in general. Future expansion, and then things to consider in general here. We'd like to look at some questions, at least, that arose were impacts to cows and wildlife usage once troughs are installed. So some of these seeps, or at least some of the seeps in the areas, are developed, and cows drink out of established troughs that have put in. So we'd like to know, how would cow activity and how would wildlife activity change at those particular sites? We'd also like to look at water quality. So when you think about cows using the same water that wildlife drink out of, we'd like to think about water quality, amount of free water. So surface water, at times some of the pools dried up, other times there was lots of water. Was that amount of surface water, did that impact data at all? Then seep vegetation, we know very little about the vegetation, the composition, what grows around these seeps. And then ground squirrels. One other interesting thing, as we know, ground squirrels are an interesting species in our area, but we didn't see any. And lastly, it'd be great to figure out a way to make it a little bit more efficient, because countless hours were spent sifting through images. Many hours sifting through non-animal images, many mice, many other things that didn't go into the data. Definitely interesting work, but countless hours were spent sifting through images. 20 minutes on the dot. So thank you, Dr. Chris Kidding, for putting up and maintaining cameras for 16 months. And thank you, Allison. in all of East Bay Regional Parks. A lot of fun, love the project, beautiful land to work in. So this is a seep, so a picture to get the questions going here. Seep, a little muddy depression behind that cow. But questions, I'll look forward to a live discussion here shortly. Have a good day, everyone.